Okay, so today I'm going to talk about magnetic field. So what is a magnetic field? Magnetic field is just a region of space, okay, in which a moving charge located in the magnetic field, right, experiences a magnetic force. So this force is what we call a magnetic force. Okay, so previously we have learned gravitational field and we have learned the electric field. Okay, so gravitational field, if you recall, gravitational field is just a region of space in which a mass located in it will experiences a force. Electric field is a region of space in which a charge, okay, so this charge can be moving or can be stationary. But either way, right, this charge will experiences an electric force. But for magnetic field, so magnetic field, there's a symbol called B, B field. Magnetic field, this charge must be moving. Okay. Right. So this charge must be moving in order to experiences a force. Yeah. Okay. So of course, with any fields, right, we have this thing called the field lines. For magnetic field, the field lines will flow from north to south. Okay. So right, so if you have two magnet, the north and the south pole are facing each other, the two magnets will attract. Okay, and you need to know how to draw the field lines. So the field lines will come up from the north and go into the south. Yeah, and if you have two magnet that has north pole facing each other, the magnetic field lines will look this way. And you notice that in between, there's a region of space in which there's no lines, there's no magnetic field. Yeah, okay, so this region is called the neutral point. Yeah. So if you put a moving charge right here, right, this charge can be moving, so this charge will not experience any force. Right. Okay, so of course the north needle of a compass would point in the same direction as the magnetic field lines at the respective point. So a magnetic field can be represented by so-called the lines of forces. And another very important thing is that magnetic field lines are vectors, like your kinematics, right? Your acceleration, your velocity are vectors. Vectors are something that has both your magnitude and your direction. So and another thing is that field lines must not overlap each other. Be it your gravitational field line, your electric field line, your magnetic field lines also must not overlap each other. Why is that so? Because if the field lines are, let's just say I have two field lines, the first is pointing in this direction, the second will point in this direction. So notice that if I have at this particular point the two field lines intersect each other, this will create another field lines. Alright, so it's something like a resultant force. If you have two forces acting intersecting each other, you will create another force, another resultant force. Alright, so field lines must not overlap each other, and field lines are denser in region of higher magnetic field strength. So the density of our field lines will indicate the strength of our magnetic field. So if your lines are denser means closer to each other, right? The strength will be bigger, right? Okay, so look at this. So you notice that we have quite the density of line are very close to each other. So I can conclude that at this point, at this region, the magnetic field are stronger as compared to this particular region. Okay, so this particular region, the magnetic field is weaker because the field lines are further away from one another. Okay, so how is uniform magnetic field being represented in terms of all those like diagram and arrows? So uniform magnetic fields means that the magnetic field strength is the same at every point. Okay, so if you have a very if you have a uniform magnetic field, the magnetic fields must be parallel to one another. Okay, parallel to each other. Yeah, so of course in a region of magnetic field there can be strong field and weaker field, but the commonality between these two diagrams is that they are the field lines are parallel to one another. The only difference is that because this is stronger, right, the field lines are closer to one another as compared to the second diagram, which is further away from one another. Okay, of course, last but not least, you have non-uniform magnetic field. The magnetic field lines cannot be parallel. They must be like they must not be parallel lah. Okay, yeah. So this region is a stronger magnetic field, but this region is a weaker magnetic field. Right.